Now for the next question, what we're doing is we're having a look at this. Looking at people doing basketball. This dude, Anthony or Noah, I don't know. Anthony was shooting. He's shooting into the basket. We've got his friend Noah was watching this happen. Might have recorded or something. I don't know. Tell us that the ball travels with a path that can be modeled with this here. Where H represents feet and X represents horizontal distance. So basically we've got our questions here. So what's the height of the ball when it reaches the highest point? Complete the square using CAS, state the height. What's the height in inches? Sorry, what's the height in feet when the ball is released? Suppose Anthony did score a swish, how far from his feet did it land? And how far from Anthony will the ball be 8 feet in the air? Okay, so let's have a look at this. So here is a series of things. H equals negative 0.7x squared plus 1.506 plus 6.696. And I forgot the x there, and I'm loving the sixes. I'm going to have a lot of fun putting that into CAS. So basically, these type of things is where you use your CAS, because you can't complete the square. You can't really do this in your head. Then taking out common factors and things, as I say, just put it into CAS and go from there. So H equals, so we're going to go into this thing. We're going to say negative 0.7, negative 0, whoops, negate 0.07, I think it is, x squared. Let's just check that. 0.07 x squared, yep, plus 1.506, 1.506x plus, or is it a minus? It's a plus 6.696. That's our thing. So I'm just going to press enter just so I've got it there. Alright, so what we're going to do is we are now going to complete the square. So we want to find the height of the ball when it reaches its highest point. So we're going to say complete square, or we'll go to menu algebra, complete the square, and we'll go, I'm just going to press the up arrow key to bring that up, and I'm going to say comma x. I'm going to close that, and it's completed the square for me. So that's pretty annoying, that one there. So the height of the ball will be that. So he wants to know the height of the ball when it reaches its highest point, complete the square. So that ends up happening here. So that's this value, because we normally write it as being, as this goes first. Let's say copy. And we'll have copy plus. That's where we normally write it. This is a x minus h all squared plus k. That's how we normally write it, but CAS gives it to us like this, so it's important that we realize that our constant, just our number without any x's involved, is our turning point, the y corner of our turning point. So we end up with a total height, a maximum height of 14.96, sorry, 14.8 feet high. Let's say part B, what is the height in feet when the ball is released? Well, what we do, we want to try and find the height here. Like it says, when the ball is released, the ball gets released here. What is the height? What do we have to let x equal? Well, we've got to let x equal 0. So what we do is we'll go up to this thing. Sorry, press enter. We'll go up to this thing, and instead of x, we're going to put 0. 0, and I think we'll get 6.696. What do we know? Because that is our y coordinate, or our y-intercept. So that's what we get for that. So that's the height when the ball is released. Suppose Anthony did score a swish. How many feet away did it land? So he's thrown it from here. It's gone up. It's gone through the ring. It's done a swish. The net's gone a little bit funny. And then it's landed over here. So we're trying to work out what this point is. Well, that point is our x-intercept. So that's what we're going to try to do. So what we'll do is we'll say we're going to let this thing here equal 0. So what we'll do is we'll say solve, menu, algebra, solve. Where is it? Sorry. No. So I didn't look at here. Menu, algebra, solve. We're going to go up and press the up arrow key right to the top to that thing. And we'll say, where does that equal 0? We're solving for x. So that's all that I've done there. And it gives me a 2 value. So it tells me it happens at negative 3.78 154 or at 25.29. Now, one of these is real, the other is not. Or sorry, one of these can actually happen. So tell us we've got one here at -3, the other one here at 25. Which one's going to be the correct one? Well, it's got to be 25 because he has thrown it from 0, from where x equals 0. So this is our answer, 25 point, you might say 25.3 feet away. Okay, now, how far away from Anthony will the ball be 8 feet in the air? So what we want, so we've got the ball being 10 feet in the air about here. We want to find out where it's going to be 8 feet. So it's going to be about here. So a couple of ways we can do that. We can either graph it, or we can let our equation equal 8. So that's what we'll do. So we're going to do exactly the same thing as what we did here. So just going up and pressing enter. But instead of 0, I'm saying it's going to happen at 8. We're going to see where that is. So it tells us the ball is 8 feet in height when it is 0.9 feet away from Anthony and when it is 20 feet away from Anthony. Now, like I said, we could have done that by graphing that as well. So we would take this, and take my equation, and copy that, copy, I'm going to go to a new graph, I'm going to paste it in, and then I'll change my domain, or rather my window zoom, window settings, -1, I'm going to go to say 30, I'm going to go to -1, and I'm going to go up to say 15. So there it is. So now I will draw a line at 8, and I'll look to see where they intersect. Analyze graph, intersection, lower, upper, 0.904. That should be the same. Yes, this we get a much more exact answer by doing this. Now we look at our next one. Menu, analyze, intersection, 20.6. Have a look at this, 20.6, and now we have 20.6. So that's how we can find out how far away the ball is when it is 8 feet in the air. So for this question, we have completed the square. We have found a height when x equals 0, so where it starts. We score how far away it goes, so we found the other x-intercept, and we have also found how far away it'll be 8 feet in the air.